Now let us start with the second part in the unit 1, which is ordinary differential equation. So the first part was the vectors and the second part is the ordinary differential equations. So let us see what is meant by an ordinary differential equation. In physics we have come across many equations like F is equal to ma. I can write the same equation as F is equal to m into dv by dt. We know that acceleration is nothing but the rate of change of velocity with respect to time. I can also write the same equation as v is nothing but dr by dt. So it will be md square r upon dt square. We have also seen equation like this. We have come across angular velocity d theta upon dt. So here you can see that this displacement is a function of a time. Here the velocity is a function of a time. So this angular momentum is a function of a time. Here the angular displacement is a function of a time. Okay, so in physics, whenever there is some physical quantity which is a function of something, so another physical quantity, what is mean by function of? So this one physical quantity depends on another physical quantity. This is called as a one physical quantity is a function of another physical quantity. For example, so this displacement is a one physical quantity, angular displacement, and it depends on another physical quantity which is a time. And in mathematics we show this as d theta upon dt. Okay, or we write it as a dr upon dt. Suppose I have a particle moving along the x-axis, along positive x-axis. Okay, the particle is moving from this place to this place. So it has started from say O and it has reached to some point A in time t. Okay, it has reached to the point B in time t2. Okay, so if the particle is moving from one place to another place in time t1, if the same particle is moving to point B in time t2, then I can say that the position of the particle is a function of a time. And how we denote it mathematically? So the position of the particle depends on the time. Okay, and in mathematics we represent it by the differential equation. Okay, now we can see that this position of the particle is a function of the time. Okay, so this entity depends on this physical quantity, right? So the position vector or the position of the particle is called as a dependent variable. And the time on which it depends, it is called as an independent variable. So I can say that the ordinary differential equation is a relation between the dependent variable and independent variable, which means that the physical quantity which is dependent on another physical quantity is written as d theta upon dt or dr upon dt or dv by dt. Okay, it means that this this is a dependent variable is written in a numerator, and independent variable is written in a denominator. And what is the meaning of this dv by dt? V is a function of t, so this we write it as a function of t. It means that this velocity depends on time. Okay, this we can write as r is function of a t, so this theta is a function of a t. See, in a physics there are many branches like classical mechanics, thermodynamics, quantum mechanics, then statistical mechanics, material science, solid state physics, whatever. Nuclear and particle physics. So there are different branches of the physics like classical mechanics, quantum mechanics, thermodynamics, statistical mechanics, nuclear and particle physics, material science, solid state physics, electrodynamics, electronics. Okay, so all these are the branches of the physics, and all these branches requires the ordinary differential equations to state any equation or to state dependence of the one physical quantity over the another physical quantity. In physics, we calculate the many physical quantities, and these physical quantities are dependent on the another physical quantities, and the relation between the dependent variable with the independent variable is denoted by this ordinary differential equations. Differential equation is the relation between the dependent physical quantity to the independent physical quantity, okay, which can be written as d by d of some dependent physical quantity to the independent physical quantity. So let us see some famous physics equations in the different branches. Okay, so when I deal with the quantum mechanics, there is a very famous equation called as a Schrodinger's time dependent and time independent equation. I will write one of it. So this is minus h cross square upon 2m dou square psi upon dou x square is equal to I h cross dou psi upon dou t. So this is the equation from the quantum mechanics. Okay, so from here we can say that this psi is a function of x and t. Okay, so this psi is a function of x as well as t. Okay, when I deal with the classical mechanics, there is a one more famous equation. So this is a Schrodinger's equation. Okay, so now I am going to write the Lagrangian equation from classical mechanics. Okay, so it is written as d by dt of dou L upon dou x dot minus dou L upon dou x is equal to 0. Okay, and d by dt of dou L upon dou theta dot minus dou L upon dou theta is equal to 0. So these are the Lagrangian equation of the motions in a classical mechanics for a simple pendulum. Okay, so we can see that thermodynamics also consists of many ordinary differential equations, as we know that this du is equal to Tds minus Pdv. This is one more famous equation from the thermodynamics, and from this equation I can write dou T upon dou V, which is equal to dou T upon dou S, keeping the volume constant. Okay, and in Newton's laws of motion we have already studied. So this F is equal to m into t square r upon dt square. Okay. So there are some properties of the ordinary differential equations. So the equations like this, okay, in which there is only one independent variable. So these are called as the ordinary differential equations. Okay, so the differential equations in which there is only one independent variable. So these equations are called as the ordinary differential equations, and the equations in which there are more than one independent variable, then these physical quantities, then these differential equations are called partial differential equations. So the differential equations in which there is only one independent variable, the equations are called as the ordinary differential equations. These are also first order and second order. We are going to see what is meant by the order and degree of the differential equation. But the equations in which there is only one independent variable, these equations are called as ordinary differential equations. And the equation which consists of more than one independent variable, like this, for example, if you see this equation, in this you can see that there is x is one independent variable and this t is another independent variable. So the psi is a function of x and t. So there are more than one independent variables. So these equations are called as a partial differential equations. So here this r is a function of only t. Okay, but here the psi is a function of x and t. So such a kind of equations. So the Lagrangian equations, Schrodinger's equations, and the equations like this in thermodynamics are the partial differential equations, and the simple equations which are in which there is only one independent variable, these are called as the ordinary differential equations. Okay, so let us see what is the order and degree of a differential equation. So the highest order of the derivative, okay, that is nothing but the order. The order of the derivative is nothing but the order of the differential equation. So here d square is there, so this is the second order. This also, here dou square is also there, therefore it is the second order. But here see, you can derivative, so this is 1, so order will be d by dt. Okay, there is only one d by dt, therefore its order will be 1. And what is the degree? So this was order of the derivative, and degree of the derivative is the degree of the differential equation. So this is raised to 1. So the degree will be 1. When you are dealing with the physics, whichever branch you are dealing with, okay, you need ordinary differential equation if you are measuring one physical quantity with respect to the another physical quantity, and mathematically it is given in the form of a ordinary differential equations.